Or do it every day. You're just usually late. You come in. This is all being recorded right now, so it'll be in the message. Talia usually shows up late, and so she doesn't see me do that. Everybody get that that's listening? All right. Okay, here we go. Yesterday, we looked at, and we just did it. You can do division, either synthetic or long division, to get the remainder. All right? Or you can take the A value. How do you find the A value? Whatever makes the divisor 0. So in this case, A is -1. If you put that A value into the polynomial, and if this is our polynomial, we sub it in. What's -1 cubed? -1 minus 2 times 1 minus 4, and I get -7. That is the remainder. If I did this with synthetic, you don't have to write this down. I'll just do it quickly. -3, -7. There's your remainder. Okay. So you can do either the actual division to get the remainder of -7, or if you just need the remainder, and we're going to learn why you need the remainder, you can just plug in the A value to get the remainder. Okay? Just putting in the A value into the polynomial will give you the remainder if you divide by that, x minus A. Is that okay? All right. This is called the remainder theorem. Pretty clever name, huh? And all it says is when a polynomial function p of x is divided by the binomial x minus a, the remainder is obtained is equal to the value of the polynomial when x is equal to a, i.e., just put a into the function. That's all it says. And if you want the proof, this is a quick little proof. We write things as dq plus r. Okay? The divisor is x minus a by definition. So if you do P of A, whatever's in brackets goes where? In for X. So it goes in for that X right there. So you end up with A minus A, which is 0. 0 times Q is nothing. So you're left with R. That's a little proof, if you didn't believe me. And then this essentially is the remainder theorem. P of A is equal to R. All you need to remember is if you put the A value into the function, it spits out the remainder. Okay? All right, flip the page, please. So the most basic question you could get are these. Use the remainder theorem to find the remainder when this polynomial is divided by x plus 1 and 2x minus 1. What do I do? Find the A value. Okay, so what's the A value for the first one? All right, what do I do with that A value? Plug it in for x. -12. People agree with that? Or are you just going to write down and trust me? That's a mistake. I'm not good at my job. Okay. The only slight trick is something that looks like the second one. What is the A value for this? Positive 1/2. Because remember, you set it equal to 0. If you don't see it, you can solve. So that is your A value. So we just have to do it with a fraction. And we're not going to write, and look, on a test or something, if you do a decimal, I don't care. But we're going to do it with fractions here. What is 1/2 to the power of 3? 1/8. 1/2 to the power of 2 is 1/4. And 8 times 1/2 is 4. I guess I could reduce that, couldn't I? How do you add fractions?
Make the 36 over 4.
Yeah, in common denominator, which would be 36 over 4. And then just add the numerators. There's your answer. If you can simplify it, sorry, or what? I don't care if you give me a decimal, but you need to be comfortable with fractions if, well, when we do rational expressions or rational functions, and trig and stuff has fractions in it as well. So, like, I don't care if you give me the decimal, but on my tests, like, the answers would be, if this was a multiple choice question on a test, the answer would be 39 over 4. They'd all be fractional form. But you could just match that up with the decimal. And if you're going to take calculus, you need to be comfortable with fractions as well. All right, are we okay with that? Basically, if you need to find the remainder, just plug in the a value. That's it. That's all it's saying. Okay? We're not going to do the rest of the page because it's kind of similar stuff. I want to go over here. And we talked about this yesterday. The factor theorem. Factor theorem says that x minus a is a factor of the polynomial if p of a is equal to 0, i.e., if the remainder equals 0, then x minus a is a factor. Do you know what I mean when I say a factor? That's true. But like when we're doing polynomials, it's like a set of brackets. Like x plus 2 is a factor. So if we did, we'll just do one that we know we can factor. This first one here, x squared plus 2x minus 24. We're going to show that this is a factor. Okay. Let's not do synthetic division. If I just said factor that quadratic, what would you do?
Factor the x.
So what multiplies the negative 24 and adds to 2? Yeah. So we're not going to do synthetic. So this polynomial is the same as x plus 6, x minus 4. Does everybody agree with that? Yeah. Those two brackets are called factors. Okay? So we can see that x minus 4 is a factor because I factored the polynomial. Now, factor theorem says if the remainder is 0, then we know it is. So it's a way to test it before you actually do the whole factoring thing. So what is, using x minus 4, what's my a value? Positive 4. So if I put my a value 4 into this polynomial, I should get 0. I should get a remainder of 0. So let's see if that works. 4 squared is 16 plus 8. 16 and 8, 24, which gives me 0. Okay. Is that okay? So if it is a factor, i.e. it's a set of brackets that can be, like when you factor the polynomial, the remainder will always be 0. So they can write these things in different ways. if you see something like this, P of 3 is equal to 0, that is your A value. And they've said that it equals 0. So what does that mean? It means x minus 3 is a factor. Okay, because you always write it as, what is it? It's always x minus a. Okay. So this one, P of negative 2/3 is equal to 0. That's your A value. They want us to write it with integral coefficients. Do you know what integral coefficients means? Whole numbers, no fractions. So normally we would go, well, that just means that x plus 2/3 is the factor. But what is the other way to write this with integral coefficients so that I get an A value of negative 2/3? 3x plus 2. That's how they want you to write it. When they say integral coefficients, they want that. They don't want the x plus 2/3. And do you understand why it's plus?
Yeah.
Because it's like x minus a, I could go x minus, my A value is negative 2/3 like that, so they switch the signs. All right. If I say P of 5 is equal to P of negative 2 and they both equal 0, determine a second degree factor of the polynomial. So that's your A value. That's another A value. What are those factors? What's the factor for A value of 5? X minus 5. What about negative 2? X plus 2. What type of equation is that?
Quadratic?
That's a quadratic. If you multiplied it out, you'd get x squared minus 3x minus 10. All right. Use the factor theorem to determine which of the following is a factor. So we're just going to do the first one because it's, well, we'll just do the first one. So to determine if it's a factor, what is the remainder? It has to be 0. If it's not 0, it's not a factor. So if I just say, is this a factor? All you have to do, I know the A value is negative 2. So then we go P of negative 2 and plug it into the polynomial. Just watch your signs. So that's negative 8, 4. Negative 90. So is it a factor?
No.
Nope. We're not going to do the other one because it is a factor. It would just give 0. So if it doesn't equal 0, it's not a factor. And that's the important thing. Because that's the next lesson. How do you determine if something is a factor? And then what do you do with it? All right. So this says, show that one is a root of the equation and find the other roots. Roots are just another way of saying factors or x-intercepts. Okay? So 1, this is your A value. So if I say find the other roots, I'm saying factor this. How do we factor it? What's the only thing we've learned so far in this unit? Long division or synthetic division. So we have to divide it. Okay? So we're essentially dividing, if this is my A value, that means the factor is x minus 1. We're dividing this polynomial by x minus 1. You can do long division if you want. I'm going to do synthetic. Okay? because we only use linear denominators in this. So synthetic, or sorry, positive 1 goes out there. Do I need a placeholder for this? Nope. So I got a remainder of 0, which is good. That means that x minus 1 is a root or a factor. So if I write this as dq plus r, divisor is x minus 1. Quotient, if we started with a cubic and we divide by a linear, we should get a quadratic. If they say they want the other roots, they want you to factor it. Can you factor that quadratic? Well, multiplies to 12 and adds to negative 8. There you go. So this whole thing is x minus 1, x minus 6, oops, x minus 2. That's it. That's all they wanted you to do. All right, so the takeaway is, if you need the remainder, just put in the a value. If that remainder is 0, then the x minus a, or whatever the binomial is a factor of the polynomial. The only questions I want you to do are 1, 7, and 11, please.